Recently, there has been a lot of talk about DeepSeek, which is a Chinese large language model that is comparable to the latest OpenAI models. Interestingly, the cost of training and the cost of using DeepSeek are only a few % of the cost of the OpenAI model, and moreover, this model is publicly available as an open source. In this material, we will try to create a simple database agent that translates natural language into SQL queries using DeepSeek and .NET 9. Of course, instead of DeepSeek, we could use other models available through Ollama for this purpose. If you are new to the channel, make sure to subscribe. To run DeepSeek locally, we can choose one of two options. Either simply install Ollama locally, directly on our disk, or do it through Docker. In this example, I will show you how to install Ollama directly through the installer without using Docker, because it is easier to do this. Also, this option will make it easier to run the Ollama models on GPU, as there is no need to install additional tools for Docker to support running the models on the GPU. So just go to the ollama.com website and click the download button, and depending on the operating system you are currently working on, you will download the installer for macOS, Linux, or Windows. I already have the LLM installed on the system, so I'll skip this part. However, after installation, you can easily check in the default terminal, either by running the Ollama command with the v parameter. Here, you have information about which version the Ollama has been installed. So if you see similar output, then the Ollama is installed correctly on your system as well. The next step will be downloading and running the DeepSeek model, which we can find in the Models tab. And here we actually have all available open source models, which we can run through Ollama. And going into specific ones for a given model, we often have different possibilities in terms of the number of parameters, on the basis of which a given model has been trained. For DeepSeek, there are several options, and we have such a very small model, which takes a little more than 1 gigabyte. However, the default option is a version that is approximately 5 gigabytes, and here we can just install it, or simply executing Ollama run DeepSeek, or just install the same model with the Ollama run DeepSeek R1 command. So just copy this command and run it in any terminal. And for the first time, of course, Ollama will need a moment to download this model locally to your disk, and then run it directly within a given terminal. So here we can already communicate with this model simply by entering our prompts directly to the terminal. Maybe, for example, I will ask DeepSeek what .NET is. After a while, DeepSeek replied to me by typing the output to the console. Moreover, I have DeepSeek running on my machine on the GPU, and to do this, it is enough to set the environment variable Ollama GPU to value 1, and that's sufficient for Ollama to run all language models on the GPU, if the GPU is supported by Ollama. Let's go to the code and see how we can connect the .NET application, written in C# to the DeepSeek model, which is currently running on my local machine. For this purpose, the first step is to install a package called Microsoft Extensions.ai Ollama. As we can see, it is currently still in the preview version. So it is important to mark the pre-release option in your IDE, which will display this kind of packages as a pre-release version. So I will install it into my application, and after a while, we can simply add a chat instance that will connect to our model locally. For this purpose, maybe we will first create a chat client, which is available from the Microsoft Extensions.ai namespace. I'll just call it Chat Client, and I will create a new client for Ollama, which is an object called Ollama Chat Client, which takes 2 parameters. The first parameter of the constructor will be the URL address under which the language model is hosted, and if you use Ollama, with hostname localhost and port 11434, and the second parameter of this constructor is the name of the given model, which is exactly the same name that we launched with the ollama.run command, and in this case, it will simply be DeepSeek pause R1. Okay, so now we actually have a connection to our local DeepSeek model. Maybe what we'll do is just take the question from the end user, which is the console, and then we will send this question further to DeepSeek. Using the DeepSeek response, we will send it back to the console. So first, maybe by changing the user message, it will get the result from the console, readline method, but maybe before that, we'll add a simple console, write line, with the command enter your prompt for DeepSeek, and then having already such a message taken from the user, having this object type chat client, we actually have two methods on it, which make our message be processed by the DeepSeek model. It will be either complete async, or it will be the method complete streaming async, which returns async enumerable. And now, depending on whether we want to wait for the entire message within one response, or we just want to return each part as quickly as possible, we either choose the option complete async or just complete streaming async. Maybe as part of the demonstration, we will first use the complete async method, to which we have to give values under the object list type chat message. So before we call it, we'll just create a list type chat message, for which I'll add one value as a chat message object, and here we have to specify the role, i.e. whether it's a system, whether it's a user, whether it's an assistant, and in our case, it's a chat message object. And here we have to specify that we want to send a message to the user first, so we'll just create a new object, type chat message, with the parameters chatrole.user and our user message value, which we'll take from the user console. And now we can pass these messages, i.e. the variable messages, to the complete async method, which we'll then wait for with the keyword await. And we'll write the whole thing, let's say, under some variable result. And now we have a chat completion object, which will provide us with a result through the object message, and then the text value. So maybe we'll write this information to the console to display the information to the end user generated by DeepSeek. So actually, that's enough to connect to DeepSeek, which works locally using Olema directly from the console, giving any prompt. Let's start the application and see if DeepSeek really answers my question. So now in the console, I'll ask maybe what is C#. As we can see now, our program has been suspended for a while. And this is of course because DeepSeek needed some time to render the entire message and only return it, finished, directly to the user console. As I mentioned earlier, the second option, which is to display every part generated by DeepSeek separately, is just an option from the complete streaming async method, but now instead of assigning the whole to the result, we'll just have to get these pieces from the for each loop, and for example, under the chunk variable, we have our result as a streaming chat completion update object on which we have the text value, and this time, if we run our program again, then maybe we'll ask the same question again. So, what is C#? And notice that now every part of this response is rendered automatically without having to wait for the entire message at the same time. We just have a more interactive way to display messages from the chat client object. So in this way, we've managed to connect to DeepSeek locally with the C# code level, and now to make DeepSeek meet our requirements. So to be some kind of helpful SQL agent, maybe first let's see what the database looks like, because it will be necessary for the DeepSeek context how these tables are connected to each other, and what are the limitations if we had this kind of data in our database. This is an example database which I will use in the context of testing the DeepSeek agent. It will be the AdventureWorks database, in which we have several tables with addresses, clients, products, product categories, description or product model, as well as order details. So in total, around 10 database tables. So now to get the schema of this database, it would be enough to create a simple script for each table separately, considering important references such as the main keys or the foreign keys. of a given table separately, and then the whole thing we will have to pass to DeepSeek in the context form before our user will send his question. We will add this user message at the very end. So I will call the method messages_that to this user message. But first, we will create a few more objects, such as the chat message, where this time the role of the chat will be just a system role, and we will give some examples here based on the requirements and the database scheme. I'll just instruct DeepSeek that it is a TSQL expert writing queries based on the user requirements. Of course, that without the database scheme, the DeepSeek model will be useless. So maybe in one more command, i.e. in the new message, where the role of the chat will be a system, and I'll just paste the entire database scheme with all of constraints as a create table command for each table separately, hoping that now DeepSeek will read the database scheme, and based on the questions that we send to the console, it will refer to a specific SQL command to extract specific information from our database. So once again, I will run the program, and this time I will ask specific questions in the context of my database. So let it be a question that I want to answer. Let's ask, how many product categories are there? As you can see, DeepSeek processes this request, analyzing the database schema to formulate the appropriate query. And after a while, in response, we should get a CQRS question that will calculate the number of categories in the table with product categories. Maybe as part of the test, I will just copy this command, and after executing it, in our AdventureWorks database, as we can see, we actually have a working SQL command. Maybe now I will run our project again, and this time I will ask a slightly more difficult question so that DeepSeek will write a list of all product categories. And we will see if it will actually be able to write a SQL question that will give me information about what product categories exist in my database. As we can see this time, we have a slightly different SQL question because DeepSeek has already forgot about the scheme of a given table, and I already know that it will fail. So just to make sure, I will run it on the same database. As we can see, we are getting a SQL error that the product category table has not been found because it has a scheme called SalesLT. Now, what can we do to solve this type of problem with the results of the AI agent? Well, to improve the AI agent's responses, we need to provide more specific context about the database schema. First of all, we need more context to make sure that in this particular case, he always considers the table scheme from which he answers the example questions. So maybe we just add one more chat message with information about DeepSeek always considering the table scheme, which in my example is just SalesLT. And this time, I hope that DeepSeek will answer the same question so that he will write down all product categories. As we can see, after a while, DeepSeek has already considered the table scheme, which is called SalesLT. Let's check if this query won't fail as last time on the database. And as you can see, it was done correctly. But here, I personally would stick to this condition in this particular case, as it is not needed. So here's our little success. We managed to teach DeepSeek not to forget about the table scheme. Maybe let's do one more small test, and this time I will ask DeepSeek to write down all the products that are in the socks category. As you can see here, he has to combine two tables, filter the data properly, and return information about these products, which are in the socks category. And this time, after a while, he did it quite sensibly. So maybe I'll just execute the command again, directly on the database. But as you can see, this time he made a mistake on the inner join clause. Instead of connecting the product category ID on the base of the key, he did it in a slightly different way. So as you can see, he was close, but he didn't quite get to the bottom of this problem. To sum up, we can very simply use the new package available in .NET 9, which is Microsoft Extensions AI, use the client Onoma Chat client, in which we will specify which endpoint and model we are locally interested in, and then for a given agent, we can assign a context, simply as a prompt object, such as a chat message, to which, as the last message, we will send information taken from the user. We will perform the function complete streaming async, which will send us an answer directly from DeepSeek. Of course, here we could also add a chat function, so not just a single response, but just iterations, adding both the answer generated by the DeepSeek model and a question from the user. And by maintaining this conversation history, we can iterate and refine responses based on the ongoing context. And then adding one more question from the user. And in this way, we could iterate on the basis of a context that would refer to the previous answer from the user of this program. This allows the model to provide more accurate and relevant SQL queries.